Hello everybody, this is very first time we are creating totally English video. For sure you are hear this voice in Turkish as well, but we have very special guest at the moment. Here is the Global Industrial Director of Renewables Energy of Megger. It's very little bit long, but I think I say the truth, right?
That's correct, yes.
Mr. Ahmed, very welcome to my office, my studio.
Thank you very much. Thank you for having me. It's really nice to be here.
It's also very nice to you here. We try to get many information from you. We have many devices on the desk at the moment.
Yes.
I really excited what is these devices and what they work. Also, we try to make some hands-on, real experimental measurements at the outside of my greenhouse.
Absolutely.
We are very lucky to catch you in here in Istanbul. Again, I say thank you.
Thank you very much for having me. It's a pleasure to be in Istanbul and in Turkey, a very industrious country with lots of potential and lots of really good things happening.
Thank you. I start with my questions. We already create some key frames of this talk. For example, the current developments in solar energy sector, maybe renewable energy sector in Turkey, also rest of the world. What we can say?
Things are happening so quickly, and developments are, especially in renewable energy and in solar energy in particular, is moving very, very quickly across the world. And Turkey is not an exception. Actually, Turkey is one of the leaders in many ways. The technology is moving very rapidly. So ever since maybe 2012, the price of how much it costs us to install or get a 1 kilowatt hour of solar panels reduced, like it was a threshold moment, which made it economically viable. But ever since then, it's kept on reducing, efficiencies kept on getting better, technology kept on improving. All the components around it, optimizers, inverters, everything is improving at quite a rapid exponential rate, which accelerated the growth of solar. And China, the US, they're leading the way, but the whole world is moving towards solar very, very quickly.
Yes, and during these improvements and the technological benefits come out very fastly, but installation not only enough. We have to measure it.
Yes.
We have to, in Turkey, we many times, especially at the universities, says that if you measure it, you can manage it.
Yes.
That's the key point, right?
That's the key point. And I mean, from our background, coming in from the Megger side, Megger is all about testing, measuring, and ensuring that things are safe, electrically safe. I don't know, maybe in the audience, people don't know the name Megger, but a lot of people in the electrical world know the name Megger. It's a very old company, started in Britain, in the UK, 1889, so very old company. Lots of history in making electrical measurements, and the very first device that Megger produced into the world is the insulation resistance tester. A lot of people refer to it as a Megger tester or Megger testing, so the brand name became synonymous with that particular early test. And the core reason for that test, an insulation test, is testing the insulation that stops electricity from flowing where it shouldn't flow. Keep it flowing in the cable and not go outside of the cable, for example. The core reason for that is safety. You don't want electricity. Electricity is a form of energy that can be quite dangerous if it flows where it shouldn't flow. So part of my mission with this role in Megger is to make sure that all this installation that's happening with solar in particular is done in a safe way. We've seen lots of examples of solar panel rooftop solar panels catching fire in worst case scenario. In other cases, it's not producing what you're expecting to produce. So you invested money, you're hoping for a certain amount of electricity to be produced, but it's not producing that. And if you don't test it, you don't measure what's going on where, you won't realize that there's a problem, or there's a problem that's developing and is getting worse and worse. And then in the worst case scenario, you might have an electric fire. So that's the core of the mission, and what Megger, from the very beginning, over 135 years plus, it's all been, the focus is electrical safety, making sure an installation is installed in a safe manner and it's continuing to operate in a safe manner.
Yes, this is very key point and most important point of the installation, I think. And on the other hand, emerging trends, for example, PV panel technologies, the maximum string voltage levels also goes up. And what Megger do, because you have to also upgrade your devices.
Yes. Yeah. So if you go back maybe 10 years, it was very common that the design of a string is 600 volts.
600, yes.
That's kind of maximum. And then it crept up to 1,000. Now it's 1,500 is for new larger installations, industrial scale installations. That's common. But inverter manufacturers are now showcasing and selling 2,000 volt inverters.
Yes.
So the strings
central inverters.
So jumping up again in voltage. And the voltage jumps up, but also the current and the total power is jumping up as well. Mm-hmm. Things are becoming more efficient. You can get more out of the same square meter of sunshine falling. So it's moving at such a rapid rate. We have to make sure that the right type of equipment is available so you can check the installation of a 2,000 volt system. But 1,500 volt became the norm only maybe 2 years ago. And we're already going to 2,000, and then who knows in another 2 years where we're going to be. But this is also reflective in the standards, like the IEC standards or in North America IEEE standards. Things are moving so quickly, and those standards, because I myself sit in standard committees myself in IEC and others, it takes us between 2 to 3 years to sit in a committee, do the research, and agree the standards and the limits that should be applied. So in 2 to 3 years, we do the research, we provide the new standard, but technology has already moved.
Yes.
So the standards are quite a little bit behind where the technology is at the moment, and the speed of it is a challenge, not just for the manufacturers of test equipment ourselves, but also the people who are trying to design these new systems. There's no clear guidance on what to look for. Things are moving so fast.
In that point, I came a question in my mind. These regulation creators don't any cooperate with you for the next generation voltage level systems, such as we try to 3K voltage system. Prepare yourself. This kind of stuff.
Well, speaking from experience sitting in IEC committees and even British standard committees I sat in the past, when we try to do that, we try to set up like a working group to research where we think things are heading. But as you're working through it, there's so many factors driving the market. There's the economics, there's the political, there's even the choices of the design engineers. If something picks up and becomes easier to scale, that particular trajectory, becomes the dominant one, mm-hmm. and what you were thinking is going to go is not where it goes. So it makes it quite difficult to try to guess where the industry is going to be in 5 years, and then start to do your research in order to meet it there. Because it always goes slightly different from where you expect.
It's hard to catch it up at the very soon.
Yes.
It takes time.
And the electrical industry, up until this, I always like to call it a revolution that's happening. Up until this solar energy, in the last maybe 20 years, the electric industry is very slow industry to change. It's very stable. Everybody needs electricity. You generate it the traditional, conventional way, whether it's a gas-fired power station or coal or hydroelectric, whichever it is. And you generate electricity, you distribute it out. It's all heading one direction from a big electric plant. You go out, distribute it, and get it down to the houses and the offices and the buildings. But now things are changing dramatically. Electricity is being generated at the location where it's being used. Decentralized. And electricity is flowing in two directions. Mm-hmm. So in the morning, the house could be sending electricity into the grid, and in the evening, it's taking it back out from the grid. And the change is so dramatic. It's so, I like to think of it a little bit like when the internet first came, started the 90s to the 2000s, and the dot-com bubble, and just everything just changing so dramatically, affecting newspapers, affecting how people do business, the emergence of e-commerce. Things just very rapidly changed, and this is what's happening in the electrical industry at the moment, is things are changing quite rapidly. The traditional way of doing things is not keeping up.
Yes, I am totally agree with you. In Turkey, decentralized system, electrical system should be as soon as possible. I always try to explain to people, but it's not easy. Many different difficulties in that things. Maybe the number one is financial problems to get money to create this revolution. But we have to exchange our electricity distribution lines with decentralized system. Also, prosumer, the word is very special and unique thing, and people, they create their own electricity. Electricity independency is very special thing. I every time try to explain this. Also, if we change the scale from the residential, also the security and the safety very important for the house level, because children are there, people are living there. On the other hand, the industrial zone, the biggest areas and the biggest and different kind of maybe different dynamics for the industrial scale power plants. But the residential solution, we have to more careful. In that side, what kind of devices we can use?
Sure.
We little bit come into the product.
And the product level, yes. On the industrial scale or the residential scale, the challenges are similar. It's just that you're dealing with a higher power density when you go to industrial. What we've seen when we do surveys in Europe, in North America, is that in a lot of instances, or a very common thing is an installation is done. They click the solar panels, click everything together, connect the inverter, connect everything. The green light is there, job done, they go. So there's very little testing being done on average. And the most common problem we've seen is surveys that we did ourselves, surveys that similar companies have done, is that there's a big problem with the earthing or the grounding. Which is usually the green or the brown wire connection. So even with DC, it's just the red and the black. But there's always the frame is grounded, or in the inverter you have a ground connection. And the ground connection a lot of times gets ignored or not thought of, because electricity is produced even if you don't have the ground connected. However, the safety devices that will detect that there's a fault current, they're looking at how much current is flowing into the ground. There'll always be a little tiny amount of current, but if it shoots up, there's a problem, and you activate and you do a disconnection automatically. If that ground connection is not there, or the resistance of it is high because it's not been connected properly, then these safety devices are not going to see a problem. Problem happens, and then they're not going to activate. The fault energy will continue to flow, and then you have a fault, you have a problem. So I have there's lots of footage and videos on the internet available. I can maybe share a little bit later, where a rooftop fire is happening, and they're more common to happen on an industrial or larger rooftop, because have more spaces, higher energy density. But the problem with when it happens there is, because the sun is still shining, the solar panels are still going to be producing energy and pushing it in. So unless there's a disconnect system that activates when a fault happens, they're just going to keep pumping energy. What we've seen in the rooftop fires, whether industrial or residential, is that once they start going, they can just keep reigniting. So there's footage of fire department coming to a warehouse. So the warehouse had lots of solar panels. Fire started. They put out the fire. When trying to clear up, it started again. Put it out. A few minutes later, it started again. And that's because the sun is still shining, so energy is still being pumped into a system that has been compromised. What we say is, from the very beginning, you need to check that your grounding is there and that it's a nice low resistance connection. So if there's any fault energy, it will flow through uninterrupted, or very minimal resistance to it, so that the safety devices that are monitoring that get the signal and activate quickly to save the place from damage. So when it comes to tools, the main tool that we push for that is either a continuity tester, so testing the continuity of the earthing or ground connection, or a low resistance milliohm meter, sometimes it's called. We call it a low resistance ohm meter, an LRO. And this is probably one of the main ones. This is a model called the DLRO2.
Maybe we can show that way.
Yeah, DLRO2X. So this is a low resistance ohm meter. So it's more than a continuity. And the difference with it is that it's a 4-wire measurement. So it takes 4 wires to make a low resistance measurement. What is unique about it is that it's accurate down to 0.1 of a microohm. So you can measure extremely low resistances. So it's very useful when measuring kind of a bus bar resistance or the resistance of the grounding connection. When doing an installation, I'm on a mission to make sure people do this test, especially at installation and whenever you do a kind of maintenance, because it's the thing that's going to save the installation from a bad fault. When we did our survey, we found, and we did our survey in the UK, Western Europe, and North America, we found that 50% of sites, industrial and residential together, 50% of sites had inadequate earthing. There's another organization based in the US. They did a much bigger survey. They had a larger sample, but only in North America. They're called Clean Energy Associates. When they did their survey, 600 sites, almost 90% had inadequate earthing.
90%.
90%. Because once electricity is flowing, you're like, oh, job done. This is the silent third party that needs to be checked to make sure that it's there and it's ready to be the insurance, be the safety.
This is also general perception in Turkey. They do it and give electricity. It's working. It's okay.
It's okay.
And we can go out.
Yeah. And as long as there's no fault, it's fine.
Yes.
But what if a fault happens?
Yes.
And a fault could be, anything could create a fault. You know, the insulation on the cable could, during installation, it might have been cut, or it's sitting maybe bent slightly, tight bend on it.
Mm-hmm.
Over time, maybe it'll take a year, maybe 2 years, but the area where you have it bent tight, it's going to break. The sun is shining on it,
Yes.
the weather, all those impact on something that is being bent tightly, the insulation will break down. Well, then that's a source of a fault current. And if you don't have your earthing or grounding connection there to spot that there's a fault to earth, that's a problem that's just waiting to happen.
Thank you for the comprehensive information about this topic. I want to ask you about the installer companies, Europe companies, maybe American companies, also Turkish installer companies, how they try to understand your devices, how much they want to use it, their mentality. I try to understand.
What I've seen is when we discuss in detail like this situation about earthing, most people they want to do a good job.
Mm-hmm.
They want to have a happy customer, happy client when they do the installation for them. So when they understand the importance, understand how easy it is to do the test, it doesn't take a very long time. You just do the connections, you measure between the two, see the nice low resistance, job done. If the resistance is a little bit high, investigate where the problem is, fix it. And once you do that, you have no headaches, no problems. A site could be running for years with no issues. So once people understand that, they want to do it. They want to do the right thing and make sure that the work they do, they're proud of. So the biggest problem is lack of understanding or lack of knowledge of what is available and what you need to look out for. That's the biggest problem. A secondary problem, which fortunately is not the common thing, is when people are under pressure, time pressure, mm-hmm. to deliver a project and move on to the next. And when they're under that kind of pressure, that's when the pressure drives them to cut some corners or to skip some steps because they're under so much pressure. Fortunately, that's not the most common thing, but it happens, and that's a recipe for disaster.
It's always happen.
Yeah, but that's a recipe for disaster. You don't want to, especially with energy that can cause problems. If this is something that the worst case scenario is okay, something's not going to work. Like maybe you're installing a printer. Worst case scenario, it's not going to print. It's not a problem. But installing a solar installation, worst case scenario, electric fire. And this is a very big problem. The risk or the severity of the risk is high. So don't cut corners.
Yes, for sure. Thank you for the information. And we also see many devices in here.
Yes.
Also in that part, especially in solar energy sector, which devices we use, especially growing up in Europe, America, Turkey as well. For that devices also need very safety work.
Yes.
And what kind of devices should we use?
Yeah, that's a good point. Let me do a reference to probably the most, at the moment, the standard that gives you the most detail when it comes to the installation of solar is the IEC standard 62446. So that one, it breaks down the electrical testing into 3 categories, but the first one, category 1 testing, is mandatory. Whether it's small scale, single panel, or it's a large scale, category 1 tests should be done at commissioning and at maintenance. Category 2 are optional, very useful tests, should be done when you can. And then category 3 are fault finding tests, type of tests you need to fault find. So when it comes to the category 1 tests, there's 7 tests in particular. So this particular product is, we call it a DCM, a digital clamp multimeter. So with the clamp side here, you can measure current, and you can measure AC current or DC current. And this particular model can do up to 2,000 amps. So you can go all the way up to large solar systems. And then from the other side, you can measure the voltage. And with this one, you can measure up to 2,000 volts, ready to go. So a device like this for measuring open circuit voltage, short circuit current, operational voltage, operational current. These are tests that should be done. Category 1, you should always do them, but always with reference to the irradiance. So this is our smallest irradiance meter. So you could put that on the panel itself, perpendicular to the panel, get a measure of how much irradiance is currently falling while you're measuring the current and voltage coming out. And based on that, you have a starting point that you're producing what you should be producing at that level of irradiance.
Oh, very nice. This device, I never heard that before. Very small and useful, I think.
Yeah, so we have another one that it does 3 things: irradiance, temperature, and inclination, so inclinometer, all in one. So, but that one's a little bit bigger. This is our smallest one, and it's just irradiance. But you need that reference when you're, in order to make sense of the voltage and the current. Like, is the voltage and current the right level?
Yes.
How do you know? Check the irradiance.
It gives more idea about what you should measure.
Yes.
Very nice. Very
so
nice.
Those are the starting points. And then still in the category 1, we go back to the continuity or the bonding resistance of the grounding.
This is a joker device, we can say.
Yes. So that test is still, it's one of the category 1 tests that has to be done. And then the big one is the insulation test. So this is MIT2500. So this one can measure insulation resistance with voltages up to 2,500 volts. So at the moment, this is the smallest 2.5 kV insulation tester in the world, with all the regular safety stuff that we have as standard in Megger. So obviously, when you're testing insulation on a string of panels, you normally do it during the daylight, so there's active voltage. But with our type of instruments, you can still do the insulation test. And the insulation test is, for me, a lot of people understand the insulation test. So when I ask people who are doing installation, what testing have you done? Usually they just say this one. They default to this one, which great, because any insulation weakness, whether in the panels or the cables or the connections, that is a big problem. So the way insulation test works, if I can give you a little bit of a background, an insulation test, you push high voltage into what it is you're testing, and you test between where the conductor is and the insulation, the ground connection. So the thing in between is you're trying to push energy through the insulation itself, whether it's like a cable. So the core of the cable plus the ground on the outside. And we're getting a resistance measurement in ohms of the insulation. And if there's along that insulation any weakness, any cut, any break, the insulation, the electricity will find a way to flow through that into the ground connection. So the insulation resistance will be low. So in the standards, for example, a 1,000 volt system, you test it with 1,000 volts of insulation voltage from the insulation tester, and you're looking for a minimum 1 mega ohm resistance for your insulation, for the insulation.
If everything is going good, 1 megawatt ohm.
1 mega ohm, minimum.
Minimum.
Normally, a new installation, you should see gigaohms, like 10, 100 gigaohms of resistance. As it gets older, as it degrades, insulation, like you have a insulation like this, like a cable like this with the MC connectors. If I just leave this on the shelf, after a few years, the insulation will degrade on its own. It'll age, like everything.
Yes.
And if it's sitting outside in the sun, ultraviolet rays, the heat, the rain, the aging happens faster. So I tested this year, it's 100 gigaohms. I tested next year, maybe it's 90. The year after, maybe it's 80. But at some point, when it gets too old, the insulation resistance year to year is going to drop slowly, but at some point it's going to drop very dramatically. And that's the point where it's too old now. You need to change it. And if you do annual inspection like this, you will see the trend and you will see when it starts to drop, because that's the point where you need to change it. Because if the insulation resistance starts to drop quickly and you're getting close to that 1 mega ohm, if I test this year and it's 10 mega ohms, then next year maybe it'll be 1 mega. And if it hits the 1 mega ohm, that's the point where the insulation is going to fail at the normal operating voltage, and then you have a big problem.
After your explanation, I get another question in my mind. Everything goes age, but also this device goes age, and it needs calibrations.
Yeah.
Can you tell me about the process of calibration? For example, in Turkish market, if you sell these devices to an installer 1 year later, 2 years later, when they come back for calibration?
The devices, the old Megger devices before the digital technology, you have to calibrate every year.
Every year?
Have to, yes. These ones are a lot more stable, the new devices. So what we say is you still want to check the calibration, maybe check it like once a year. So you need like a reference resistance, and you just do the test, and there's a procedure of just checking at different voltages. You're seeing that the value is still within the tolerance that we give you, and it's fine. As soon as it goes outside of that, then you need to recalibrate. But it's very common that these devices, 3 years, 4 years, they still don't need to be calibrated because you just do the check. It's still within the spec, you're fine. But the older devices that were more analog, they needed to be recalibrated every year.
Okay. You can trust these devices, Megger devices, and you can use it without any calibration. Maybe only just test it.
Just check.
But in general, many years you can work properly.
So we have an accessory called the CB calibration box. It's not for doing calibration, it's for checking the calibration. So we have a CB100, CB101, and different models. So with that CB box, it's a small box. You connect to it. On the bottom, we give you the exact value of the resistors in that particular box with the percentage tolerance. And then you do the measurement, and as long as the value is within the percentage tolerance for that value of the resistor, you're good.
The installer also can buy this device?
Yes.
Oh, it's very nice.
Yes.
The new information for me about your device.
So you can, and the way we design our devices, we make sure the components in there have a lifespan of 20 years. But depending on how people use them, how rough they are,
for sure.
We're confident our devices will last minimum 5 years, 10 years average. So the investment is for somebody who's going to be using this for many years. So the return on investment should be very, very good for an installer who buys our equipment.
Very nice. I get information, I learn something, and explain to people the most what I want to create content for people. This is very nice for me as well. Thank you. We talk about everything, I think, but this device maybe.
Oh, yes.
Will you
Sure.
tell us?
I'll tell you a little bit. This is one of our newer devices. This is we call this the MPAC. It's a acoustic imaging camera. I'll turn it on a little bit. So what it is on the back it has microphones as well as an actual camera. And we have different models of this. The most recent model is the 208 model. And the 208, it has 208 microphones.
208
microphones, yes.
Oh.
And what it can do is it has multiple applications. So one is it can pick up on acoustic sounds. And the reason you have lots of microphones is to be able to isolate and figure out exactly where the sound is and how much it is. And by doing this kind of sound detection, if it's a mechanical space, you can see vibration. You can see gas leaks, for example. But when it comes to electricity in particular, we can see partial discharges. So when it happens in the audible range, you hear the buzz of electricity, partially discharging. You often see that next to maybe transformers or connections like overhead cable connections at the point where they are connecting to the insulator. You can sometimes hear it. Well, this one you can hear in the above the 20 kilohertz. So this one can go up to 120 kilohertz. And you can pick up partial discharges when they're first starting. So you can visually see there is partial discharge happening at that point. So it's a very useful tool for just walking around the site and doing an inspection. And what's great about the 208 is This particular one is the 128, so it's the lower spec model. The 208, the new one, has thermal camera with it. So you can do thermal camera inspection, check for partial discharge with the acoustics, and then if the installation maybe has some gas pipes, something like that, you can also check for any leakages with that as well. It is a general purpose type of inspection camera, but it combines a lot of different things. At the moment, we haven't released it, but we're even looking at having it as part of a drone, so you can actually do drone surveys, looking for acoustics, looking for thermal imaging, and checking just for problems, and isolating exactly where they are, especially on a larger site.
As you explained here, I am very excited because you measure everything, right?
Yes. Yeah, we're constantly looking where are the problems and what can we do to measure the problem so we can detect it and quantify how big of a problem it is. And Megger, as part of this world that is developing so quickly, we're also investing and moving into monitoring. So having installed sensors and bringing that information centrally and having some more intelligence to pick up different data points and actually come up with a conclusion, like based on the temperature and the weather, the irradiance, and how much energy is coming out, and a few other sensors maybe you've installed. We have an assessment that everything's running fine, or everything is fine except for that string. And between these two panels, there seems to be an issue. So you're having insights. That's not something that's available right now, but that's the direction we're going, because that's the direction that the industry is going.
Thank you very much for comprehensive explanation about your devices. I am feel lucky today. I learn a lot. On the other hand, I am also an engineer, and I really like to see this kind of device on my desk. This is also very unique time for me.
I like to see people who are enthusiastic about this. I'm enthusiastic about renewable energy and the opportunity to having energy independence. So you're generating your own electricity on a residential level as well as like a nation level is really important, not just economically, but security-wise. To be self-reliant, self-dependent is a good thing.
Yes.
And solar energy is one of the ways we can be. So I like meeting people like yourself who are excited and interested and want to learn more. And I want to learn more from you as well, so that we deliver solar energy safely to more people here.
I want to ask you about the category 2 measurements, especially IV curves. Many solar PV power plants every time call me at the moment, says that we have to measure IV curves. We try to learn more details about our devices. Do you have any work about the IV curve devices for Megger?
Yeah, so Megger has been working on IV curve tracing for a while. So just to review the IEC standard 62446, it breaks down testing into the mandatory category 1 tests, then the optional, very useful category 2 tests, and then the fault finding tests. So we covered previously the category 1 tests, like insulation and the continuity and voltage and current and so on. When it comes to IV curve trace, a lot of people get asked to do this. So they're the installer, and then they get asked to do an IV curve trace. And in many instances, not everybody, but in many instances, they don't fully understand what the IV curve trace is for. They've just been asked to do it. So they need to find a device, do the test, and supply the information to their client. IV curve tracing, it's a quick test. So you connect to your string. You normally do it by a string, not single panel, but it's possible to do it with a single panel. And what you're measuring is the open circuit voltage, and you then doing a quick short circuit to get a short circuit current. And you're looking at the voltage versus current graph, and you're looking to see how it drops from high voltage with no current to high current with little voltage. So you're looking at that curve. The manufacturers of solar panels will publish that at this temperature with this much irradiance, the IV curve should look like this.
Standard test
Gives
conditions.
you a standard, yes. So when you do it in the field, you're basically doing comparison to what the manufacturer said it should be like. So the way we do it in our device that will be released soon is you're getting a percentage difference from the reference. So at the voltage and corrected for the irradiance, corrected for the temperature, you get your curve. And is that curve 100% of what it should be? Or is it 90, 80, 50? So that is the first reference point, because you're getting a measure of, is the string producing what it should be, number one. but then also the shape of the curve. If it's not a nice smooth knee shape curve, that will be an indication of issues within the string. So depending on, is it wavy at the top? Is it reduced at the top, but then everything else follows what it should be? Is it wavy at the bottom? All of these things are indications what kind of a possible problem you have in the string. So what we've done with our IV curve tracer, it does the full test for this of the string, and it'll give you the percentage difference of where it should be and where you are. But then if there are like phenomenons within the curve, it will give you possibilities of what the problems are. So it can say high likelihood of shading issues, high likelihood of faulty panel within the string. So it actually gives you indications of what the possible problems are that are causing this.
Maybe cloudy weather and mismatching, mismeasurements.
Exactly. So it's part of the cleverness of not just doing the test, but actually getting insight from the test. So you actually, it's not just an exercise of I've done it, here you are, it's been done. No, I've done it, and the result or the insight from the test is this.
Thank you. This is very useful information for me as well. I want to ask you about the shadow topic. One of the biggest problem of the PV panels. I always explain to people, Superman see the kryptonite and it goes down, and the PV panels see the shadow and goes down.
It goes down.
And
yes.
Is there any device? Is there any work about measurement of the shadow or something like that?
Yeah, so shade evaluation tools, we're working on that as well, and we're working on that with some of the partners. Usually at the beginning, when someone is designing a solar installation, you do a shade evaluation at that point to see what kind of shading you're going to get during the day. Is there a tree? And then you mitigate for that in the design. But then afterwards it's been installed, things happen, trees grow, and so on. You still need to do a shade evaluation every once in a while to see how it is. And I like your analogy with the kryptonite for Superman.
You can use everywhere.
I will. But what I always try to explain to people is a solar panel is made of multiple cells. And if within the same panel, just one cell has a leaf on it or has some shadow on it, but the rest is fine, what would happen, especially if the protection electronics on the panel are not working as well as they should, is that the other panels that are having full light will try to push energy into the cell that is not producing as much. So you're getting this cyclic effect of energy flowing within the panel itself instead of flowing out of the panel. And that's when you start getting overheating of specific cells within the full panel. So shading can be the start of a problem that then all that energy, the blocking diodes and the bypass diodes, especially the bypass diodes, bypass the cell that is got some shading. If they're over time getting a lot of stress of doing their job because that particular cell is being a load, being a sink for the others, eventually they'll wear out and fail, and then you'll have a hotspot within the panel. And that's when you come with a thermal camera and you can see the hotspot. That particular cell is overheating. And as it overheats, it ages, it breaks down, and then you have it's a domino.
Maybe.
Yeah, cracking can happen because of all that heating. So it becomes a domino effect. So it started with shading, maybe a leaf, and then it's just a domino effect of problem leading to another problem, leading to another problem, and then eventually it can lead to electric fire in worst case scenario down the road. So shade evaluation is and a shade evaluation tool is very useful as just inspecting the site to make sure that it's still the same site, the same the way it was been designed. That amount of shading that it has been designed for is still applicable. So it's a very useful tool to have. But we in the IEC standard, that is seen as an optional test, and it's seen as a fault finding test. So in the fault finding tests, the diode testing is seen as fault finding because not all solar panels are made with blocking diodes and bypass diodes, but that is the common design architecture. And they're very important devices to make sure that electricity flows out
yes.
and not like circulates. So if you do an IV curve trace and you see a bit of a waviness, and if you're using our device, for example, and it tells you there might be some diode issue, then you use a diode tester. And we have a product here that has diode testing mode within it. Mm-hmm. And you can test specifically the diode junctions in the back of the panel just to see, are they still active? Are they still able to block energy as they should.
Working properly or
not. Because even if they start to degrade and they're not blocking as much as they used to, then that's going to cause the heating and the circulation of energy within the panel.
Very nice to talk with you also. Understand the device and measurements, details, very important also for my side. I want to ask you, we measure many things, okay, that's good, but how can we see the results? Is there any reports or report button or something like that?
Yes. All our instruments come in different models, and we always have a model that has Bluetooth connectivity or USB connectivity. So this particular model here has Bluetooth in it. Mm-hmm. This one has both Bluetooth, and if you bring it down, it also has a direct USB connection. Mm-hmm. So all of them have the ability to save data internally, so it even has a save button, mm-hmm. And then transfer that data digitally. What we've done recently is we have a software platform called Cert Suite, mm-hmm. so Certification Suite. It's a cloud-based software, so you just you can have a free license or the paid license for professionals. You log in online just on a web browser into your account, and then the instruments that have Bluetooth can connect through your laptop or through your phone to Cert Suite, and we have an app for Apple and Android. Mm-hmm. So the device can connect through Bluetooth to your phone or your tablet or your laptop, connect to that app or the web browser, and then as you're doing the testing, you're automatically filling out your report. So the way we tell people to do it is before you go out to the job, you open up your Cert Suite and you make the plan of what you're going to do. I'm going to do this type of test on this string, on that panel. You've designed what it is you're going to do already. Then you go to the site with your instruments, you do your measurements and automatically fill them out. And when you're done, you can add some maybe pictures or some text notes, and then you click generate and it'll generate a certificate of test, which is then you can print out or send as a PDF file by email to the client. So that's how we tie it all together, because you might have different products. In one site you have the full list of testing you need to do. On another site maybe it's a smaller list. So it changes from job to job, and it can all be tied together with that Cert Suite platform.
Yes, this is also important for some of customers. They want to see the reports and observe the values in the reports. They like it. Yeah. Analytical thinking idea. Most of the time, most customers like to get a report from the installer, and you can make a free version and for professional a paid version.
Yeah, so the free version, there's standard reports, and mm-hmm. then you're filling them in. If you want to do your own thing, have your own different reports, you have a team, so you have a single account with lots of people mm-hmm. going out in different places and feeding back in, then the professional license, the paid license is the way to go.
Thank you for today. You gave us a lot of information about your products, and my last question about the thermal imaging. Is there any work about this topic?
Oh yes, we have a new range, multiple different cameras, different price points for thermal imaging. And we even have like the combined one with the acoustic imager as well. But we have standalone thermal cameras, different price points. And thermal imaging, even though the IC standard has it as an optional category 2 test, it's become like the number one maintenance survey method. Even now there are drones with thermal cameras, so you can do multiple sites. So you can hover over a rooftop for, if you have multiple houses you look after, you can do multiple ones with your drone. And the thermal imaging, for it to work, you need a minimum amount of irradiance. So there's enough energy being produced, because you're looking for hotspots. And the hotspots is where you have problems, because everything should be similar temperature. There should be very little change in temperature. Maybe one area is getting a little bit more sunshine because of the angle. Mm-hmm. So there's a little bit of increase here versus there, but overall it's uniform. As soon as you spot actual spots where there is extra temperature, that's an area to investigate. And whether that is that a shading issue, or is that a crack within the solar panels that is then causing the overheating. There's another side to the thermal cameras that sometimes people overlook. On the back side of the panels, so most of the time I see people do the survey on the front side of the panel, so the side that the sun is facing, which is great. You should do that. But then on the back side, especially the MC4 connectors, these connectors here can be a weak point. What we've seen is that people are sometimes, because of pressures, because of supply, and they need to finish a project, they have one connector, like a female side connector from one manufacturer, and then the other one from another manufacturer, and they force it together. I mean, the connection is there, electricity is flowing, but it's not the way it should. Yeah. Yes. And if you do a thermal imaging survey on the bottom side, you will spot hotspots at this point. And that's where you know that there's an issue. Because these connectors, you have a clip on this side and you have the male side in between, and they're supposed to fix together. If there's even a small gap, maybe electricity can flow, but the resistance is high. And if there's a high resistance, it produces heat, and the thermal camera can spot.
And losses as well.
And losses,
and total efficiency goes down.
Goes down, absolutely.
Small, but in total years, after the years, it's a very big amount of energy you lose.
Yes, absolutely. So we've seen this issue. I've got pictures I can share with you later where you can actually see the just the connection point itself heating up. Mm-hmm. Everything else is cool and it's just hot right there. So you know that there's an issue, a practical trick. So you're out to do a survey, but it's a bit cloudy. It's not a sunny day. So you don't have enough irradiance to have enough energy for your thermal camera to pick up the problems. One way to induce the issue is to use an insulation tester and actually inject your voltage into it. So you inject it and hold it for maybe 10 minutes, and these things will light up where there's issues. So you can do a combination of an insulation test, an active insulation test, and a thermal camera survey at the same time. You'll discover problems. So it's
nice tip.
It is a nice tip. It's not the standard thing. You're just doing an insulation test, you finish that, and then you do a thermal. But sometimes you can combine these things, and it'll help.
Today we get a lot of information, most of the solar devices in here. Mr. Ahmed, thank you so much.
Thank you for having me. Thank you. Let me share a little bit, and I look forward to sharing some more as we develop even more.
Thank you. I hope you enjoy and learn a lot of things about the Megger devices, especially renewable measurement devices. If you like this video, like it, share it, and subscribe. See you next video.